Let me welcome you here in my YouTube channel, my Tech Toolbox. Good day. I'm glad that you find it here, and I hope that you're just fine as well.
Maintenance, otherwise known as technical maintenance, refers to a set of processes and practices that aim to ensure the continuous and efficient operation of machinery, equipment, and other types of assets typically used in business. Proper selection of the type and effective implementation is essential to the successful performance and longevity of machinery, assets, facilities, and entire businesses. Today, I will present and discuss for you the different types of maintenance that you can select from that application on your maintenance assets. Before we get into them, let's look back at the causes, purpose, and benefits of implementing maintenance. The primary mission of maintenance is to ensure the reliable and efficient operation of equipment, facilities, and assets, thereby maximizing their lifespan and minimizing downtime and associated costs. This involves a range of activities from routine upkeep to proactive repairs, all aimed at preventing failures, optimizing performance, and ensuring safety. What is equipment failure? Equipment failure refers to the malfunction, breakdown, or inability of machinery, tools, or devices to perform their intended function. It occurs when a part of equipment ceases to operate efficiently, disrupting the normal functioning of system operations. Equipment breakdown, mechanical failure, system outage, technical malfunction, and equipment downtime are terms used instead of equipment failure. Equipment failure can be a major setback for any business, leading to downtime, increased costs, and potential safety hazards. Understanding the common causes of equipment failure and implementing appropriate measures is essential to maintain operational efficiency and protect valuable assets. By taking necessary precautions, businesses can minimize the risk of equipment failure, optimize productivity, and ensure smooth operations. In short, maintenance should be implemented to prevent equipment failure. Types of machine failures. 1. Mechanical failure. A. Breakdown of moving parts. When the moving components of machinery or equipment fail, it can lead to unexpected stoppages, decreased productivity, and potential damage to other parts. B. Misalignments and imbalances. Misalignments or imbalances in machinery can cause excessive wear and tear, reduced performance, increased energy consumption, and potential safety risks. 2. Electrical failure. A. Power surges and electrical issues. Power surges or electrical issues can damage sensitive equipment, disrupt operations, cause data loss, and pose safety hazards to workers. B. Circuit overload and short circuits. Circuit overloads or short circuits can result in equipment malfunctions, production interruptions, electrical fires, and costly repairs. 3. Software or firmware failure on automated or computerized equipment. A. Bugs and glitches. Software or firmware failures can lead to system crashes, errors, and malfunctions, impacting the accuracy, efficiency, and reliability of automated processes. B. Incompatibility issues and data corruption. Incompatibility issues or data corruption in software or firmware can hinder communication between equipment, cause data loss, compromise product quality, and disrupt shop floor operations. Those are the most common types of equipment failure which affects operational performance. Successful maintenance implementation can bring about considerable benefits for the company. Benefits of maintenance. In general, businesses benefit from good maintenance practices. However, several factors need to be considered before you can determine if maintenance is helping your organization. 1. Increased longevity of assets. Having the patience and dedication to regularly inspect, clean, and care for an expensive asset helps operations maximize productivity and cut costs by preventing expensive repairs and replacements. 2. Optimize asset performance. A well-maintained asset operates at maximum capacity, positively affecting business ROI through efficiency and consistency. 3. Avoid unscheduled downtimes. Unexpected breakdowns can cause significant problems for any business. Diligent maintenance can help businesses avoid unexpected outages, ensuring operations run smoothly and without any hiccups. 4. Minimize costs. Most industrial machines used for business operations cost a small fortune, so it only makes sense to diligently maintain these assets to get the most out of them. Failure to implement good maintenance practices will lead to machine breakdowns, costing the business more money through avoidable repairs and replacements. I now present to you the different types of maintenance, and I would like to start with two important definitions so we will be at the same page or having the same understanding. First is the definition of the term type of maintenance. It refers to an approach used to keep equipment, systems, or assets in good working order. This approach ranges from reactive, fixing problems after they occur, to proactive, preventing problems before they happen, and may involve various activities like inspections, repairs, and replacements. Second is the definition of the term maintenance strategy. It is a comprehensive plan that outlines how to care for and maintain equipment, facilities, and other assets to ensure they function reliably and efficiently. It encompasses the methods, procedures, and scheduling of maintenance activities to prevent breakdowns, minimize downtime, reduce costs, and extend the lifespan of assets. Essentially, it's a roadmap for keeping things in good working order. Let's continue. There are basically two main types of maintenance, the reactive maintenance and the proactive maintenance. Reactive maintenance, where repairs or replacements are performed only after equipment has failed or broken down. It's a fix-it-when-it-breaks approach, where maintenance is only triggered by a problem or issue that has already occurred. Proactive maintenance, on the other hand, is focused on preventing equipment failures and breakdowns before they happen. It involves identifying potential problems, addressing their root causes, and implementing preventative measures to extend the lifespan of equipment and reduce unplanned downtime. Key characteristics of reactive maintenance are 1. Post-failure. Reactive maintenance waits for a failure to occur before any maintenance work is done. 2. No planning. It involves no pre-planned inspections or scheduled maintenance activities. 3. Immediate repairs. Once a failure is identified, the focus is on quickly restoring the equipment to operational condition. 4. Suitable for low-cost assets. It's often used for assets where the cost of a failure is relatively low and the consequences of downtime are minimal. Target application of reactive maintenance are 1. Non-critical assets. Reactive maintenance might be appropriate for non-critical equipment where a failure doesn't cause significant disruption or cost. 2. Low-cost components. For items like light bulbs, where replacement is simple and inexpensive, reactive maintenance is often sufficient. 3. Situations with minimal consequences. When a failure doesn't impact production, safety, or other critical operations. Examples of reactive maintenance works are changing a light bulb, a common example of reactive maintenance, as you only change the bulb when it burns out. Repairing a pothole. Road maintenance often follows a reactive approach, with repairs only done after potholes are identified. Replacing a broken appliance. Replacing a refrigerator, washing machine, or other appliance after it breaks down is a reactive maintenance action. Advantages and disadvantages of undertaking reactive maintenance are A. Lower upfront costs. Reactive maintenance can be less expensive upfront, as there are no scheduled maintenance activities. B. Higher long-term costs. However, it can lead to higher long-term costs due to unplanned repairs, potential downtime, and increased risk of safety and environmental hazards. C. Inconvenience. Reactive maintenance can disrupt operations and lead to delays and overtime costs due to the unplanned nature of the repairs. Key aspects of proactive maintenance are identifying potential problems. Proactive maintenance involves regularly inspecting equipment, monitoring performance data, and analyzing potential failure points to anticipate issues. Addressing root causes. Instead of just fixing symptoms, proactive maintenance focuses on identifying and eliminating the underlying causes of equipment problems. Preventive measures. This includes tasks like regular lubrication, part replacements based on wear patterns, and adjustments to operating conditions to prevent failures. Examples of proactive maintenance activities are 1. Regularly lubricating machinery. Rotating components require lubrication to minimize friction and wear. 2. Monitoring vibration levels. High vibration can indicate misalignments or other issues that need to be addressed. 3. Conducting thermal imaging. Identifying hotspots can reveal potential overheating problems. 4. Performing oil analysis. Analyzing the condition of lubricants can reveal potential wear and contamination issues. 5. Inspecting and replacing components based on wear patterns. This can prevent failures before they occur. Benefits of undertaking proactive maintenance are: A. Reduced downtime. By preventing failures, proactive maintenance minimizes unexpected interruptions to operations. B. Lower maintenance costs. Addressing problems early can prevent more costly repairs or replacements later on. C. Improved equipment reliability. Proactive measures ensure equipment operates as intended for longer periods. D. Enhanced safety. By addressing potential hazards, proactive maintenance contributes to a safer working environment. E. Extended equipment lifespan. Regular maintenance helps to maximize the operational life of assets. There are some confusions about the classifications of maintenance types, the terms unplanned maintenance and the planned maintenance. Find out from whatever sources to check for the definition of those two terms. You will find out that the terms unplanned maintenance and reactive maintenance are the similar, planned maintenance and proactive maintenance are also the same. To remind us that they are similar, let us place captions on the respective heading. Let's continue. There are at least 3 kinds of reactive maintenance. 1. Emergency maintenance. Emergency maintenance is urgent, unplanned work performed in response to unexpected equipment failures or breakdowns that pose an immediate risk to safety, operations, or property. 2. Breakdown maintenance. Breakdown maintenance, also known as reactive or corrective maintenance, involves repairs and maintenance performed after equipment has failed. 3. Opportunistic maintenance. Opportunistic maintenance is a maintenance strategy where maintenance tasks are performed on equipment or components when the opportunity arises, often during a planned or unplanned shutdown of a system. Now, let's discuss some details of each type. Emergency maintenance. Emergency maintenance refers to unplanned, immediate repairs needed when an asset or piece of equipment experiences a sudden breakdown or dangerous malfunction that poses a threat to safety, property, or operational continuity. It is a reactive form of maintenance that is triggered by unexpected events and requires a rapid response to mitigate risks and restore functionality. Key characteristics of emergency maintenance. 1. Reactive. Emergency maintenance is performed in response to an unforeseen event, rather than being scheduled in advance like preventive maintenance. 2. Urgent. It requires immediate action to address a critical situation that could lead to further damage, safety hazards, or operational disruptions. 3. High priority. Emergency maintenance tasks are typically prioritized over other scheduled maintenance work due to the immediate risks involved. 4. Potential for high costs. Because it often involves overtime work, expedited parts procurement, and extended downtime, emergency maintenance can be more expensive than planned maintenance. 5. Focus on safety and functionality. The primary goal is to quickly resolve the issue and restore the asset or equipment to a safe and functional state. Breakdown maintenance. Breakdown maintenance involves repairs and maintenance performed after equipment has failed. It's a reactive approach where actions are taken only when a malfunction or failure has already occurred. It is an unplanned and unscheduled activity that have already disrupted operations, meaning repairs are needed immediately to restore functionality by fixing the broken equipment, replacing parts, or making necessary adjustment. Opportunity maintenance, also known as opportunistic maintenance, is performed when an unplanned or planned system shutdown occurs, allowing for the completion of preventive maintenance actions. It capitalizes on existing downtime to address maintenance needs that might otherwise be scheduled for later, potentially reducing overall downtime and maintenance costs. There are at least 4 different popular proactive maintenance. 1. Preventive maintenance. It is a proactive approach to maintaining equipment and assets through regular inspections, servicing, and repairs, with the goal of preventing unexpected breakdowns and minimizing downtime. It involves scheduling maintenance tasks based on time or usage to keep assets in optimal working condition. 2. Corrective maintenance is also known as reactive or breakdown maintenance. is the process of repairing or restoring equipment to its proper working condition after a failure or malfunction has occurred. It's a reactive approach, addressing issues as they arise, rather than being proactive like preventive maintenance. 3. Predictive maintenance is a maintenance activity that uses data analysis to anticipate when equipment is likely to fail, allowing for maintenance to be performed just before the failure occurs. This approach aims to optimize maintenance schedules, reduce downtime, and minimize costs associated with unexpected breakdowns. 4. Improvement maintenance's aim is identifying and implementing improvement action on equipment and service. It is an approach based on downtime's analysis to raise up equipment's performance, such as reliability, maintainability, availability, and safety. Let's discuss further down on some details of each type of maintenance under the proactive or planned maintenance. Preventive maintenance, PM. Preventive maintenance is a set of activities that are performed on plant equipment, machinery, and systems before the occurrence of a failure in order to protect them and to prevent or eliminate any degradation in their operating conditions. PM is carried out at predetermined intervals or according to prescribed criteria and intended to reduce the probability of failure or the degradation of the functioning and the effects limited. The advantage of applying PM activities is to satisfy most of maintenance objectives. It is good for those machines and facilities which their failure would cause serious production losses. Its aim is to maintain machines and facilities in such a condition that breakdowns and emergency repairs are minimized. Its activities include replacements, adjustments, major overhauls, inspections, and lubrications. Corrective Maintenance, CM. Corrective maintenance is classified under the planned maintenance. In this type of maintenance, actions such as repair, replacement, or restoration will be carried out after the occurrence of a failure in order to eliminate the source of this failure or reduce the frequency of its occurrence. Predictive Maintenance, PDM. Predictive maintenance is a set of activities that detect changes in the physical condition of equipment that are signs of failure, in order to carry out the appropriate maintenance work for maximizing the service life of equipment without increasing the risk of failure. Classified under the planned maintenance. Improvement Maintenance, IM, aims at reducing or eliminating entirely the need for maintenance. For maintenance, this means all actions aimed at extending the service life and eliminating future failures. Within the framework of improvement maintenance, one should exclude actions where the purpose of the activity is to improve the speed or quality output of machinery or equipment. Now, after having presented to you the types of maintenance in both the reactive and proactive categories, let me update our types of maintenance chart. We can now see the divisions and main types of maintenance. The reactive consists of emergency, breakdown, and opportunistic maintenance, while the proactive consists of the preventive, corrective, predictive, and improvement maintenance. Let's find out in each of the types to see what specific subtypes that belong to them. Let's continue. In the reactive maintenance category, the three maintenance types, the emergency, breakdown, and opportunistic maintenance, are all standalone in type such that there are no subtypes under them. Let's look at the four types under the proactive maintenance category. Preventive maintenance have 4 subtypes. Corrective maintenance have 3 subtypes. Predictive maintenance have 2 subtypes. And improvement maintenance have 3 subtypes. We look at the details of the subtypes, starting with the preventive maintenance. Preventive maintenance is subdivided into 4 different kinds according to the nature of its activities. 1. Running maintenance. Running maintenance, which includes those maintenance activities that are carried out while the machine or equipment is running, and they represent those activities that are performed before the actual preventive maintenance activities take place, such as inspection and performance analysis. 2. Routine maintenance. Routine maintenance, which includes those maintenance activities that are repetitive and periodic in nature, such as lubrication, cleaning, and small adjustment. 3. Window maintenance. Window maintenance, which is a set of activities that are carried out when an equipment is not required for a definite period of time. 4. Shutdown preventive maintenance. Shutdown preventive maintenance, which is a set of preventive maintenance activities that are carried out when the production line is in total stoppage situation. Corrective maintenance, CM, is composed of 3 subtypes. 1. Remedial maintenance, which is a set of corrective maintenance activities that are performed to eliminate the source of failure without interrupting the continuity of the production process. The way to carry out remedial maintenance is by taking the item to be corrected out of the production line and replacing it with reconditioned item or transferring its workload to its redundancy. 2. Deferred maintenance is a set of corrective maintenance activities that are not immediately initiated after the occurrence of a failure, but are delayed in such a way that will not affect the production process. 3. Shutdown corrective maintenance is a set of corrective maintenance activities that are performed when the production line is in total stoppage situation. The way to perform CM activities is by conducting 4 important steps: fault detection, fault isolation, fault elimination. In the fault elimination step, several actions could be taken such as adjusting, aligning, calibrating, reworking, removing, replacing, or renovation. Verification of fault elimination. Predictive maintenance, PDM, is classified into two kinds according to the methods of detecting the signs of failure. 1. Condition-based predictive maintenance. This type depends on continuous or periodic condition monitoring equipment to detect the signs of failure. Maintenance actions taken as a result of investigated condition of parts or components. The condition is measured or evaluated during programmed inspections of parts and components. 2. Methods of condition-based monitoring. First, the subjective type, which is using human senses. Second, the objective type, which is using monitoring and measuring equipment or gadgets. 2. Statistical-based predictive maintenance depends on statistical data from the meticulous recording of the stoppages of the in-plant items and components in order to develop models for predicting failures. Some important things to remember though. Note 1. The drawback of predictive maintenance is that it depends heavily on information and the correct interpretation of the information. Note 2. Some researchers classified predictive maintenance as a type of preventive maintenance. Note 3. The main difference between PM and PDM is that PDM uses monitoring the condition of machines or equipment to determine the actual mean time to failure, whereas PM depends on industrial average life statistics. Improvement maintenance, IM, is subdivided into 3 types as follows. 1. Engineering services. Engineering services, which includes construction and construction modification, removal and installation, and rearrangement of facilities. 2. Design-out maintenance. Design-out maintenance, which is a set of activities that are used to eliminate the cause of maintenance, simplify maintenance tasks, or raise machine performance. From the maintenance point of view, by redesigning those machines and facilities which are vulnerable to frequent occurrence of failure, and their long-term repair or replacement cost is very expensive. 3. Shutdown improvement maintenance. Shutdown improvement maintenance, which is a set of improvement maintenance activities that are performed while the production line is in a complete stoppage situation. At this juncture, let me update for you the types of maintenance chart based on the data and information of the different categories and subtypes. I also need to modify the arrangement to facilitate or simplify your interpretation and understanding of the data contained in the items therein. To summarize, maintenance is composed of the reactive maintenance, which is also called the unplanned maintenance, and the proactive maintenance, which is commonly called the planned maintenance. Standalone emergency, breakdown, and opportunistic maintenance types comprises the reactive maintenance. Proactive maintenance consists of the preventive maintenance with 4 subtypes, corrective maintenance with 3 subtypes, improvement maintenance also with 3 subtypes, and the predictive maintenance with 2 subtypes. These types of maintenance complete the chart. This would be your reference in determining the best maintenance type or combination of different type to apply in your facility or maintenance assets. Yes, indeed. This will be a good reference for you as maintenance practitioners. Finally, maintenance practitioners who are involved in planning, scheduling, and implementing maintenance works must understand the key elements and applications of the different types of maintenance for them to be effective. Learning this maintenance structure will develop and enhance your competencies such that you will be able to contribute to meet your department's objective that will redound to increase profitability and success of your respective company. It cannot be overstated that you will be one of the MVPs in your organization. Good luck, and thank you very much for watching.
Before leaving, may I thank you for the time you invested here. Should you still have questions and clarifications to ask, write it in the comment below or email me at mytechtoolbox@gmail.com. If you have learned something that are useful, please give us a like. That's one way to support our channel. You may also want to share this video for your friends to learn. Subscribe now so you will be notified on every new learning videos we post on YouTube. Thank you and good luck.